Welcome to this guide on how to read laptop schematic diagrams correctly and easily. Whether you're a beginner or an intermediate repair technician, this is your go-to resource for mastering schematic reading. What are laptop schematic diagrams? A laptop schematic diagram is simply a visual map of the electronic circuits inside a laptop. It shows the connections between components on the motherboard, helping you understand how everything works together. These diagrams are essential tools for troubleshooting and repairing laptops. They help you identify faulty components, trace signal paths, and greatly improve your repair success rate, all while reducing the time you spend diagnosing problems. Basic schematic symbols and components. Before you can read schematics, you need to understand the symbols used. First, we have passive components. Resistors, labeled with an R, capacitors, marked with a C, and inductors represented by an L. Next are active components. Diodes, labeled D, transistors marked Q, and integrated circuits, or ICs, shown as U. Finally, connectors and power elements, including power supplies, connectors labeled J, and the ground point, marked as ground. Let's go over some of the most common terms you'll see in laptop schematics. For power and voltage, VCC is the voltage supply for integrated circuits. GND is the ground reference point, or 0 volts. VDD is the drain voltage supply for FETs. And you'll often see 3V or 5V rails, which are common voltage values in laptops. For signals and control, CLK is the clock signal for synchronization. RST is the reset signal to initialize components. EN stands for enable, which activates certain functions. IRQ is an interrupt request signal. For data and communication, data represents a data line. ADD is an address line for memory locations. SDA and SCL are the data and clock lines for the I2C bus. TX and RX are transmit and receive communication lines. And in terms of components and interfaces, CPU is the central processing unit. GPU is the graphics processing unit. EC is the embedded controller, which manages system functions. And PCH, the platform controller hub, also known as the South Bridge. Reading circuit flow. Reading a schematic is all about following the flow. Start by tracing signal paths. First, identify power sources and ground connections. Then follow the signal flow from input to output and locate the key components and how they connect. When understanding circuit flow, remember that power flows from higher voltage to lower voltage. Signal paths typically move from left to right, and it helps to identify functional blocks such as power, data, and control. Pro tip: use colored markers to highlight different signal paths when studying complex diagrams. Best practices for reading schematics. Here are some proven techniques to master schematic reading. Start with power. Identify the power supply sections. Trace voltage rails like 3.3 volts, 5 volts, and 12 volts, and find voltage regulators and converters. Identify major components. Locate the CPU, PCH, GPU, and other ICs, along with memory modules, slots, connectors, and ports. Understand block diagrams. Study functional blocks first. See how they connect, and note the signal flow directions. Use color coding. Highlight different signal types, mark power, data, and control lines, and always keep your reference materials close. Expert tip: create your own symbol reference guide with the most common components you see in schematics. Troubleshooting with schematics. Schematics aren't just for learning, they're powerful tools for troubleshooting. First, use voltage test points to measure power levels with a multimeter. Next, perform signal tracing to locate breaks or interruptions in the circuit. You can also use the comparison method, checking against a known good schematic to find differences. And always study how components interact so you can pinpoint the faulty area. Pro tip: document your findings with notes and measurements directly on printed schematics. A solid repair workflow is: identify the symptom, locate the relevant circuit section, check power and signals, isolate the faulty component, and verify the repair. Download schematic diagrams from our blog. If you need schematics, we have you covered. Visit our blog at geniusmind4u.blogspot.com for access to a huge database of laptop schematics from all major brands: Dell, HP, Lenovo, Asus, and many more. We have over 1,000 schematics covering more than 50 brands, all free to download with easy navigation and a quick search feature. And the best part, it's available 24/7. So check it out now and get the resources you need to work smarter. Key takeaways. Let's wrap up with some key takeaways. Learn the basics, master schematic symbols and common terms to build a strong foundation. Follow signal flow, trace power and signals to understand how the circuit works. Apply best practices. Use a systematic approach for troubleshooting and repair. And finally, access more resources at geniusmind4u.blogspot.com to expand your skills. Thanks for watching, and happy repairing!